So friends, in this video, we are going to discuss about point group. This is a very important part of group theory. If a set of element fulfills the following condition, then it can be said a group. For example, suppose the first means first is suppose A, B, C are the element of a set, then they should follow such relation like AB must be equal to C or CB must be equal to A, or A square is equal to B, or C AB may be equal to BA. In such case, the element are called computable, and such group is known as abelian group. This is the law of multiplication. So, if we want to say a set as a group, then it should follow law of multiplication. There must be an element which is computable with other elements and leaves them unchanged. For example, A is that element. When it is multiplied with A, B is equal to B, A is equal to A, and it is known as law of identity. Third one is each element must follow associative law like A bracket close B C is equal to A B C, like that. There should be inverse of each element in groups, such as inverse of A is equal to A minus A as the power minus 1, and A dot A raised to the power minus 1 is equal to E. It is known as law of reciprocal of inverse. Point group of molecule shows symmetry element present in that molecule. So this is the main definition of point group. That a point group, a molecule shows that all the symmetry elements present in the molecule. The number of element group is known as order of group. So total number of elements present in that group, that is known as order of group, and it is presented with H symbol. It is possible number of the symmetry operations also. For example, the order of C2V and C3V are 4 and 6. C2V and C3 are point group, and 4 is the order of C2V point group, and 6 is the order of C3V point group. Because in C2V there are 4 elements, and in C3V there are 6 symmetric operation or elements are present. The smaller group that can be found with the bigger group is known as subgroup. It must follow condition to be called point group. These laws it should follow. If H and K are order of bigger than subgroup, then H by K should be integer. If group is having ABC element, then the following relation is known as similarity transformation, like A raised to the power minus 1 into B into A is equal to C, where C would be known as similarity transform of B by A, or B and C are conjugated. Now we have to discuss how can we find out point group. So this is the main important thing. How can we find out the point group? For that purpose, we need to go through some steps. Like first step is we have to find out the symmetry element in the molecule. How many symmetry elements and which kind of symmetry elements are present in the molecule, that we have to find out. For example, E is the present by default in any molecule. The E means identity. Identity is an element which is present in all the molecule by default. Means when blindly we can say that E is present in the molecule. Now we have to find out the principal axis. A principal axis is seen Cn. Suppose we have found out that principal axis is Cn. So if principal axis is Cn, then there may be zero number of C2 means subsidiary axis, or n number of C2 will be present as a subsidiary axis. For example, if C3 is the principal axis, then zero number of C2 will be present, or three number of C2 will be present. Similarly, if principal axis is Cn, then zero number of sigma V will be present, or n number of sigma V will be present. The condition is we have to find out at least one subsidiary axis or at least one sigma V. Then we can use this trick. For example, C3 is the principal axis, then zero number of sigma V will be present, or three number of sigma V will be or may be present. Now we have to find out the horizontal plane whether it is present in the molecule or not. If sigma V can be more than one, but sigma H will always be one. That we need to remember. We have to keep it in our mind. Similarly, if principal axis is Cn, then Sn will be present if sigma H is present, and ACS to N will be present if sigma H is absent. For example, C3 is the principal axis, then S3 will be present if sigma H is present in that molecule. But S6 may be present when sigma H is absent in that molecule. For example, CNH3. Okay, NH3. It has C3 principal axis. So there is a two possibility that Sn will be present, means S3 will be present, or S2n means S6 will be present. But we know that in NH3 there is sigma H, there is no sigma H. Sigma H is absent. Okay, so sigma is absent. Then formula says or rule says that trick says says that the S6 will be present. So ammonia has S6, improper axis of rotation. And one thing is very important, that we whenever we find out a point group, we don't consider Sn. Improper axis is not considered when a point group is finding out. So it helps us. Now the second thing is that if only principal axis present, then start the name of that point group by C. For example, in X molecule only C2 is present. Okay, so no subsidiary axis, only principal axis present, no subsidiary axis is present. Okay, so that time we have to start that point group's name by C letter only. Okay, but when Cn plus n number of C2, C2 means n number of C2 means subsidiary axis. Principal axis plus subsidiary axis, both are present, then point group's name will be started from D. So that we have to remember. What is the thing? Thing is, if principal axis is present only, then we have to start from C letter. And if PA and a subsidiary both are present, then we have to start D letter. Now this is the table which will help you, or it is actually formula like table. For example, point group is Cn, then only E always present in any molecule by default. So Cn is point group. How can we find out Cn point group? We have to find out E and Cn. If E and Cn are present, then Cn will be point group and its order will be N. Its example are S3PO4, H2O2, open book like this. If Cn for Cn point group, E will be present, then Cn will be present, and sigma V will be present. Its order will be 2n, H2O, H2O2, Cs, NH3, PBH3, all thrice. Like these are some example of SC and V point group. CNH point group, E, Cn, sigma V, sigma H. Sigma V may be or may not be, it's okay. And its point order of that group is 2n. So H2O2 trans, this is the example of this. DN, E will be present, Cn will be present, and Cn will be present. So its order is 2n, and ethylene triamine cobalt third complex is an example. DNH, now see, here we are starting from C letter, here we are starting from D letter. Why? Because here only principal axis is present, but in this case principal axis as well as subsidiary axis both are present. That's why we are starting point groups name by D letter. So DNH, E, Cn, NCN plus sigma V plus sigma H, 4n will be the order. And these are some examples. DND, E plus Cn plus n number of CVN plus sigma V. Then it is not Cn, actually it is 2. Okay, just to make it correct, this is 2, C2, C2, C2. Okay, now CS means if plane of symmetry is present only, no principal axis, no subsidiary axis, no plane of symmetry, only E plus sigma is present, then that point group will be CS. CI means only center of symmetry present, no subsidiary, principal, or plane of symmetry present, then CI. Now both order are 2 and 2. Now C1, if only E present, there is no principal axis, there is no plane, then there is no center of symmetry. So E point group will be there. So its order is 1. Lactic acid is the example. This is very important. C infinity V means C infinity is present along with sigma V. HCl and CO, linear molecules are the example. Diatomic linear molecule. Heteroatomic especially. D infinity H, C infinity, sigma H, as well as I, and one more thing that is missed, that is n number of means infinity C2 present. So linear molecule with same atom at the corner. TD tetrahedral groups, all tetrahedral, perfect tetrahedral. 24 is the order, CH4 is the example. Octahedral, all perfect octahedral. 48 is the order of group and SF4 is the example. Okay, so this table is helpful for predicting point groups. Now we will do some example in our next. We will solve some examples of point group in our next video. Thank you very much for watching this video.